Alright guys, this is part 2 of the video today on section 12-3. We just spent about 12 minutes or so looking at inscribed angles theorem and kind of some conclusions that can be made from that theorem. So, part 2 we're going to look at another theorem. It doesn't have a fancy title. Let me just point out though, because the previous theorem, the inscribed angles theorem, does have a title, you need to know that name, right? Because when you use it in a proof, again, they're not going to expect you to know the number of the theorem, because in the book we're using it says chapter 12, but I've seen in other books where it's in chapter 10, so you can't call it theorem 12-3 or anything like that. So you need to call the previous one the inscribed angles theorem. This one does not have a name, so you just need to explain the relationship in a proof. So anyway, this theorem says the angle formed by a tangent line and a chord is half the measure of the intercepted arc. So again, just kind of piece this together. We have an angle, a tangent line here, meaning if it were to continue, right, it would not touch, it would only touch the circle once. So a tangent line there, and we also have a chord going through the circle here, and its angle measure is going to be half of the intercepted arc. So the intercepted arc, again, would be this arc right here, right? The arc that it forms there. So if the arc measure in this case is 120 degrees, then we would say that the angle formed here would be half of that. So half, let's call this x, right? So x would be equals half of 120, which is 60 degrees. So this has a connection between the inscribed angles theorem. If we had an inscribed angle that formed the same arc here, that angle y would also be half of 120. So x and y in this case would actually be congruent. So that's just fun fact. Anyway, let's look at how we do this problem here. So it looks like we're solving for x, y, and z. There's a triangle inscribed in this circle. If you notice, they give you some key information here. It is an isosceles triangle, which means the base angles are the same. So that's going to come into play. So let's look at kind of how to piece this together. First of all, we can solve for y by looking here. Again, I said it's an isosceles triangle, which means that these two angles here must be congruent. So we can say that this other angle is also y. So we can say that y, or 2 times y, plus 54 equals 180 because they're in a triangle, right? So 2y must equal, subtract 54 from both sides, you get 126, therefore y equals 63. So y is 63 degrees. Excuse me. So we know y is 63 degrees. Now we are looking to find the angle x and angle z. So again, we have angle x and z are both formed by tangents, right? They're both formed by tangents and chords, which means the relationship we just learned is that x is half of this intercepted arc that I'll put in yellow here. X is half of that arc, and z, again, let me put this in a different color so you can see it. So angle z would be half of this intercepted arc here. Well, we can find out the blue arc there because we have an inscribed angle that forms that arc. That inscribed angle is here, right? So we have an angle of 54 degrees that forms the arc where that z is related to. So the relationship there would be that 54 is half of, the blue arc, let's call that A. Okay, half of the blue arc, A, which means that A is actually 108 degrees. So we know that A is actually 108 degrees. And again, Z is half of that, right? Z is half of that. which means we kind of just go back to where we were, as we just said. Z is half of 108, which means Z is actually 54. So really, do we need this step in the middle where we have to find A? We don't, because the relationship is that Z is congruent to 54 there, right? Because they're both half of the intercepted arc. So now we need to find X. Well, again, X should be congruent to Y, because, let me kind of erase this stuff in the picture so that we can kind of get a feel for this. If we're just solving for X, what do we know? Well, we know that this angle here is 63 degrees, right? We solve for that because it's, again, congruent to Y, so these two angles are the same. Well, it forms this arc, so it is half of that arc. X also forms this arc, right? The same arc with the tangent, so it's also half of that, which means, again, we can say that X is also 63 degrees. Now, one good way to check this would be that X, Y, and Z should add up to 180 because they form a straight line, right? So if they don't, that means we did something wrong, and you should never watch my videos again, because I clearly have no idea what I'm talking about. So hopefully, for the sake of my YouTube channel, that these are correct. So X, Y, and Z should add up to 180. So X is 63, Y is 63, that adds up to 126, plus Z is 54. That would take us right up to 180, which means you can keep watching, knowing that I have somewhat of an idea what I'm talking about. Anyway, here's another one. Again, this looks a little frightening, right? But we can be confident here, and just go one letter at a time, see what information is given to you, and then go from there. Okay? So it tells us that, let's see what information it gives us. It tells us that we have a central angle here of 100, which means the arc that it forms is also 100, right? The arc that it forms is also 100, which means look at that, we just found X. We just found that X is 100 degrees, because X is the arc that it forms, right? So that wasn't so bad. What else can we find? Well, we know that, let me clean up the picture here so that it doesn't get too confusing. We also know that this is a semicircle here, right? It's a semicircle, which means it's 180 degrees. So if this is 180, and this is 100, that's 280, which means this is 80 degrees, because they have to add up to 360. So just to kind of formalize that, we know that, let's see here, we know that 180 plus, oh, what did I just do? I just realized that I was thinking X was the wrong thing. My fault, guys. My fault. Let's try this problem again, shall we? X is actually this angle down here. Oh, man. Maybe you shouldn't watch my videos anymore. X is actually the angle down there, which that was very confusing as to what we did there. Well, okay. Again, apologies. We can find Z, though. We can find Z, how we were just saying to do that. So again, we know this is 100 here. We know this is 180. So Z is just, we have 100 plus 180 plus Z will all add up to 360. Therefore, Z must be 80 degrees, right? So we know Z is 80 degrees. Okay. What else do we know? We also know that this angle here, excuse me, this angle here, oh man, I'm kind of going all over the place in this problem. We know that Z is 80 degrees. We also know that we have a quadrilateral here, right? Formed by two tangent lines. And as we saw in a previous section, that this angle and this angle here must add up, must be supplementary. Again, because these two angles on the side here are congruent. Okay, this is a kite, as we've talked about in previous lessons. So we can say with confidence that y plus 100 equals 180. Therefore, y must be 80 degrees. So we have z equals 80 degrees, we have y equals 80 degrees. Now we need to figure out this angle x, right? Now we need to figure out this angle x. Alright, now, again, we're jumping back and forth from triangles to kites to circles. There's a lot of shapes that are coming into play here, so you really need to make sure you're staying focused on exactly what's happening here. So, let's look at what we have here. We have a triangle formed in here, where two of the sides are each a radius, which means they must be congruent, which again, that means we have an isosceles triangle, right? So if this angle in here is 100, well then the other two angles must, they add up to 180, and since they're congruent, the other two angles must be 40 degrees, right? So those must be 40 degrees, which means we should be able to find x. So how do we do that? Alright, let me pause for a second here. Aha! This is what I was going for before. Okay. This is true what I just told you about the 40 degrees, but I just realized that there's a better strategy that is less confusing. So hopefully you're not too frustrated with me at this point. You might be a little frustrated with me, but okay. I was looking at the wrong isosceles triangle. We know that this triangle here is isosceles because, again, we have two tangent lines that meet at a common point out here, right? They meet at a common point, which means they must be congruent. And if they are congruent, then these two base angles must be congruent. We already know that y is 80 degrees, which means we can say that 2x plus 80 will give us 180, right? Because again, they add their three interior angles of a triangle. It's isosceles, so x and 80. Subtract, we get 2x equals 100. Therefore, finally we're here. X equals 50 degrees. So, as you can tell, on a problem like this, you can really get lost in as I said before, in what, sometimes you're dealing with kites, sometimes you're dealing with triangles, isosceles triangles, the radius of the circle. You have arcs, you have intercepted arcs, you have arcs formed by a tangent and a chord, you have arcs formed by two chords. There's a lot going on. Not necessarily one way of figuring it out. There's a lot of ways to figure these things out. So you just kind of need to start playing around with things, see what's supplementary, see what forms isosceles triangles, see, what part of the triangle or what part of the circle it's occupying, etc. There's a lot of strategies that you can use here. But I will torture you no more. You can go on with your day, and hopefully I'll see you in class tomorrow. Okay? Bye guys. Have a good day.